Now, you should have multiplied polynomials in the past, and the rules are, um, when you multiply a polynomial by a binomial, use the distributive property and the properties of exponents. So for example, if I gave you something like, let me turn my marker on here, works a little bit better so you can see what I'm doing. All right, let's say I gave you something like 2x times 3x plus 5 x to the third. Okay, well, we would use distributive property here, and we'd multiply. So I end up with 2x times 3x. Now, you should remember that you can multiply the whole numbers together. So 2 times 3 is 6. And then when you multiply variables together, you just add the exponents. So x times x will give us x to the second. So 2x times 3x gives me 6x to the second plus, and then if I multiply the 2x times the 5x to the third, well, 2 times 5 is 10. And x to the first times x to the third, well, the variables are the same, so I just add the exponents. So that gives me x to the fourth. And that's the product rule here. If the bases are the same, we just add the exponents together. Okay? And that's the basic, the rule, the property of exponents that you need. We're going to be using the rest of these throughout the year, but this is the one that we'll be using mostly this week. And here's an example. If I multiply this out, we're using the distributive property. It can be more than two terms and 3 terms here, but I just multiply the first term, so x times x squared times 4 to the 4 times x times 4x, x times negative 3, and then I would multiply the 2 times x squared, 2 times the 4x, and 2 times the negative 3. So if I did that, I'd end up with, and some kids, they write it all out, which is perfectly fine, x times x squared plus x times 4x minus 3x. And then I'm going to do the 2 also, so that's going to be 2 times x squared plus 2 times 4x minus 2 times 3, which is 6. So now I'm going to try to simplify this. So x times x to the third is, x times x squared is x to the third plus x times 4x, which is 4x squared, minus 3x, so I really can't do much there, plus 2x squared, can't do much there, plus 2 times 4 times x, well, that gives me 8x minus 6. Now, I can simplify. I can add like terms together. So 4x squared and 2x squared gives me 6x squared. So my answer would be x to the third plus 6x squared. So I've used this term, this term, this term. And then minus 3x and 8x, those are the same variables to the same power, so I can add them together. Those are like terms. So that would give me plus 5x minus 6. So this would be my polynomial simplified down. And yes, you do have to simplify them down. You can't just leave things like this. You have to, add like terms together and simplify it down. So here's one that I can work out. We have a, so I'm just going to multiply this across. So a times 2, so that's going to give me 2a. A times negative 5a, and I just do this in my head, so that's negative 5a squared. A times a squared, so that's going to give me a to the third. And then now I have to multiply the negative 3 by everything. So negative 3 times 2, that gives me negative 6. I'm going to change this so I don't mess up here. So I have negative 3 times negative 5a, so that's going to give me 15a. And then I've got negative 3 times a squared, which gives me negative 3a squared. Now I'm going to put things together that are like terms. So I have a to the third. There's nothing I can put there, and I want to put it in standard form too, which highest power to lowest. So a to the third is gone. I have negative 5a squared and negative 3a squared. That gives me negative 8a squared. I've got a 2a and a 15a, so I can add that together because they're common or like terms, and minus 6. So that would be simplified down and written in standard form, like we've learned, going from the highest power to the lowest power. Always, please make sure that you always write your answers in standard form. So the key to this week is when we multiply polynomials. And let's say I gave you something like this. Let's say I just gave you a times a to the third plus 5xy. Okay, well, a times a to the third, I'm just going to write this out. A times a to the third plus 5xy times a. This is all multiplication in here. I mean, so a times a to the third, the bases are the same. I can add the exponents, so that gives me a to the fourth. Plus, now none of these variables are the same, so I just have to leave it. Usually we do it in alphabetical order when we have variables, so I would just do this as a x y, but you could have it as x y a. It doesn't make a difference, but you can't put any of those variables together because they're not the same variable. But you can still multiply them. That makes no difference. All right, let's try a practice problem here. Let's say I gave you 2 minus x times 2 plus x. Well, if I'm going to multiply this out, I like to write it out so I have room to work. All right, so I'm just going to multiply the first term times everything. So 2 times 2 and 2 times x. So 2 times 2 is 4 plus 2 times x, which is 2x. Then I've got negative x times 2. Well, that's negative 2x. And negative x times x, which is negative x squared. 2x and negative 2x just cross off. So I'm just left with 4 minus x squared. So all we're doing this week, well, that's one of the things we're doing this week, is multiplying polynomials. Now, this one's a little bit tougher because I've got 3 terms times 3 terms. Okay, again, I'm just going to write it out here so I have room to work. So I've got x squared minus 2x minus 3 times 3x squared plus 4x minus 1. All right. I'm going to change all the addition or subtraction signs and change the number directly behind just because I'd rather deal with negative signs than subtraction signs. So now I'm going to multiply the x squared times everything. All right. So I've got x squared times 3x squared. Well, that gives me 3x to the fourth. X squared times 4x. Well, that gives me 4x to the third. X squared times negative 1 is just negative 1x squared. All right, so I've got the first term out of the way. Now I've got the second term I've got to multiply by everything. All right, negative 2x times 3x squared. Well, that's negative 6x to the third. Negative 2x times 4x. Well, that gives me negative 8x squared. Negative 2x times negative 1 gives me positive 2x. All right, I still have one more term to go. I got to multiply this negative 3 times everything, and I just changed the colors here so I can see what I'm doing. So negative 3 times 3x squared, that gives me negative 9x squared. That's plus negative 9x squared. Negative 3 times 4x gives me plus negative 12x. And negative 3 times negative 1, which gives me positive 3. All right. Whew, that's a mess. So I'm going to try to put things together. So I've got 3x to the fourth. There's no other fourth term here. But I have a 4x to the third and a negative 6x to the third. That's going to give me negative 2x to the third. Those are gone. I've got a negative 1x, negative 8x squared, and a negative 9x squared. Ooh. So negative 1x squared, negative 8x squared, that gives me negative 9x squared. And another negative 9x squared, that gives me negative 18x squared. So those terms I used up. Now I've got a 2x and a negative 12x. That gives me negative 10x and plus 3. Whew, that's a lot of work. It's not difficult work, but you have to be real careful that you don't miss a term. And that's where most people mess up. They'll miss a term in there, and then it makes things real difficult. Now, what if I asked you to multiply out something like this? Okay, and this gets into the next concept this week, binomial theorem. If I asked you to multiply something like this, and I said, okay, I want you to multiply out x plus 2 quantity squared. Well, what does that mean? It means that I have to multiply x plus 2 times x plus 2. Okay, well, that's not bad. I mean, I just multiply, so that gives me x squared plus 2x plus 2x plus 4, or I get x squared plus 4x plus 4. But what happens if I asked you to do this, x plus 2 to the 5th power? Well, that means I have to multiply x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. Oh my goodness. That's going to be tough. It's going to be real tough because we have to multiply. Now, the binomial theorem gives us a really interesting way of doing problems like this. And the first thing it does is it starts off with the Pascal's triangle. Okay, and some of you are saying, I don't even know what the Pascal's triangle is. Okay, here's the Pascal's triangle. If you have a plus b to the 0 power, here's Pascal's triangle. It starts off 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And it goes by this power here. Okay, if I wanted to expand a 5th degree binomial expansion, these are the numbers that are going to be in front of that exponent. It's like, what? All right. So remember I gave you that problem, x plus 2 to the 5th power. Okay. And I said, hey, let's multiply that out. Well, this helps us immensely. What you do is you go down to the 5th degree. This term always starts off as the highest power. So I always start x to the 5th, and then I always go down 1. So x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. But you don't really have to put that in there because that's just 1. And then the other number starts off at the lowest. So you have 2 to the 0. Well, that's just 1, right? That's 0. 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. Okay, now, what are these Pascal's numbers? Well, these are the numbers that go in front. So I have to put those in also. So I put a 1 here. I put a 5 here. I put a 10 here. Put a 10 here, a 5, and a 1. Okay, and then you just simplify, and this is a plus sign, so these are all going to be pluses here. So now all I do is simplify each term. What do you mean? Well, 1 times x to the 5th times 2 to the 0. Well, 2 to the 0 is 1. 1 times 1 is 1. So my first term is x to the 5th. Okay, that's my first term. My second term is 5 times 2, x to the 4th. Well, because 2 to the 1st is just 2. So that's going to end up being 10 x to the 4th. Then my next term is going to be 2 to the 2nd. Well, 2 to the 2nd is 4. And then I have a 10 in front from Pascal's triangle. So that's going to be 40 x to the 3rd. Then my next term, I have 2 to the, I think that was a 3 here, right? 2 to the 3rd is 2 times 2 is 4 times 2 is 8 times 10. That gives me 80 x to the 2nd. See how the x's are always just going down. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd. This one, 2 to the 4th, that's 16 times 5. Is that 80 again? Plus 80x plus 2 to the 5th, which is 32, isn't it? And there, without having to multiply this, without having to multiply x plus 2 times 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 x plus 2, which would take me probably an hour or so, I've multiplied it out using the Pascal's triangle. Okay, so we started off in the beginning, I said, okay, let's do x plus 2 squared. And I said that the answer was x squared plus 4x, was that 4x plus 4, right? I think we multiply that out. Let's see if this works with Pascal's triangle. So here's the second degree. So I'm going to use Pascal's triangle here. Okay, so remember, we always start, the first term, we always start, so that's x, we start with the highest power, so that's x squared, x to the 1st, x to the 2nd. And then the second term, you always start with 0 power, so that's 2 to the 0, and then you always work up, 2 to the 1st, 2 to the 2nd. And then the last thing you do is you plug in the numbers from Pascal's triangle, 1, 2, 1. So I put a 1 here, a 2 here, and a 1 here. Okay. And then my last thing is just simplify. So 1 times x squared times 2 to the 0. Well, 2 to the 0 is 1 times 1. So my first term is x squared. Boom. My second term, 2 times 2 to the 1st. Well, 2 to the 1st is 2 times 2 is, that's 4. 4x because I had an x in there. And then x to the 0 is just 1. So 2 to the second is 4. Oh, look at that. I get the exact same answer as I got when I multiplied it out by hand. This is, and I mean, if I just had a to the second power, I wouldn't do that. But if I had something to the fifth power, I'm not multiplying x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. I'm using Pascal's triangle. And I'm just using the fact that the first term is always going to go down one exponent, and the second term is always going to go up one. It's really kind of cool. I mean, it really is. So let's try this problem here, p plus r to the fourth. Okay, so I've got, now, if you don't remember Pascal's triangle, okay, 0, if it's a 0 power, it's 1. If it's a first power, it's 1, 1. If it's a second power, it's 1, 2, 1. How am I getting these values? You always add the two numbers right above it to get the next term. So if I'm third degree, it's going to be 1, and the first term is always 1. And then 1 plus 2 is 3. 2 plus 1 is 3, and 1. So the first and last term, but I'm dealing with the fourth degree, so I got to go one more. So it's going to be 1, 4, 6, 4, 1. So these are the numbers I'm going to use for Pascal's triangle. I got to put it in front. But remember, I start with the p to the fourth. So I've got p to the fourth, p to the third, p to the second, p to the first, p to the 0. Remember, the second one, we start with 0, so that's r to the 0, r to the first, r to the second, r to the third, r to the fourth. And then we just put our numbers in from Pascal's triangle. And my numbers for Pascal's triangle is a 1, a 4, a 6, a 4, and a 1. And then I have to simplify. 1p to the fourth, r to the 0. R to the 0 is 1, so my first term is p to the fourth. Plus, so I have 4, p to the third, r, so that's 4, p to the third, r to the first. Then I've got plus 6, p squared, r squared, plus 4, p, r to the third, plus, and then p to the 0 is just 1, so I don't have to write it in, r to the fourth. I'm done. Look how quickly that was. That was less than a couple of minutes. I'd still be multiplying this out if I had to do p plus r times p plus r times p plus r times p plus r. This is my answer. Is it up there? P to the fourth, 4p to the third r, 6p squared r squared plus 4p r. Letter C. So this is called binomial expansion using Pascal's triangle. It's really kind of cool. It really saves you. Now, if you don't understand that, go ahead. You can still just multiply it all out if you want to. It does work. I mean, if you wanted to multiply this all out. But if you did that, what you'd have to do is you'd have to multiply these two together first. So, what would that give me? P squared plus 2pr plus r squared. Okay, so that takes care of two of them. Then you're going to have to multiply this times p plus r. Okay, and you can do that. And then when you get that answer, then you multiply it by another p plus r. And you'll end up with this, I guarantee you. It does work. It's kind of cool. All right, that is the lesson tutorial for this week. Hopefully I see you guys on Monday morning from 10 to 11. Bye.